Suppose the acceleration due to gravity at the Earth's surface is 10 meters per second squared, and at the surface of the Mars it is 4 meters per second squared. Okay, so G Earth is 10 and G Mars is 4 meters per second. What is G on the surface of the moon? Do you remember that? Just an additional info. It is G by 6. So around a sixth of 10. That is on moon, 1 point something. Anyways, a 60 kg passenger goes from the Earth to the Mars in a spaceship moving with a constant velocity. Neglect all other objects in the sky. Which part of the figure 2 best represents the weight, net gravitational force of the passenger as a function of time? Okay, as a function of time. And we have 4 varieties here, graph A, B, C, D. Now look, all 4 graphs here, okay, all 4 graphs have same starting point. Okay, and what is that point? That point is when t equals 0, the weight equals 600 newtons. That is justified by 60 into 10. Okay, that is verified by 60 into 10. Okay. Now, what is this end point? Same end point. This same end point would be when the passenger reaches the Martian surface. So his weight will be 60 into 4, that's 240 newtons. That will be somewhere here. Okay, that's right. Slightly below 250, I can sense, or yeah, slightly below 300. Anyways, let's consider it 240. Okay, but my main point here is this. Look, had we considered the direction of the weight, okay, had we considered the direction of the weight, suppose this is Earth and this is Mars, okay, then if the passenger were to leave the surface of the Earth, this would be the net pull on him, that is 600 newtons in this direction. Okay, and by the time he reaches on the Martian surface, what would be his weight? 240 newtons in the opposite direction. Okay, my main point is this. If we decide to pay attention to the orientation of the weight vector, then this second point should have been somewhere below. Do you agree to this? Because of the difference in the directions of the forces. But it's not that. This point is still in the first quadrant. What does it mean? It means whatever that curve is going to be, they are concerned with only the magnitude of the force. Although they say net gravitational force, from the graphs it becomes clear that this net gravitational force, it's a vector quantity, but they ask us the magnitude. They have asked us to calculate the magnitude. Have you understood this idea or this particular point?
Yes, sir.
That is negative 600 and this is positive 240. Now look, do you agree that this force variation, okay, this force variation is going to be a continuous function of time? Let me ask the question again. My question to you is, the change in the weight, okay, is not sudden. 600 newtons, then it is gradually going to decrease and then the direction will change and then it will go to 240 newtons in the other direction. Do you agree to this? So that, voice is breaking. Others?
You use it, but no.
Not now?
Not now.
Okay, let me complete this sum. and then we can I'll check my connections. Okay. So in the third part, we're going to argue like this. As magnitude of the weight is a continuous function of time. Okay, as magnitude of the weight is a continuous function of time, we can say that intermediate weight, okay, let's not get into complications, function of time, and W changes its direction it must become zero somewhere in between. Okay, so that is as good as applying the intermediate value theorem. Okay, therefore by intermediate value theorem, C is right. Why C is right? AB, the net weight never becomes zero. D, it does become zero, but becomes negative. Now we have already ruled out D because the endpoints suggest that it's the magnitude that matters and not the direction. Is that clear? So yeah, same starting point and same endpoints allowed us to conclude that in the graphs they only have given us the magnitude of the weight and they're not concerned with the direction. Okay. Now if we wanted to see this problem mathematically, okay, it would start somewhere here, okay, at -600, and it would end somewhere here. Now we are not interested in the nature of the curve. Okay, that the nature of the curve is described there. Okay, but what we want is, due to intermediate value theorem, somewhere it is going to become zero. That's what we want. Okay. All right, that is MCQ number 2.